Hello everyone, welcome back to another IB Chemistry SLHL video. Today we're going to be looking at structure 1.3.2, which is the line emission spectrum of hydrogen provides evidence for the existence of electrons in discrete energy levels, which converge at higher energies. So, to perform an experiment in which we obtain the emission or the absorption line spectrum of hydrogen gas, the first thing that we would need is a continuum source. So this would be white light. Because as we know, white light contains all of the colors in the visible light spectrum. So continuum spec. And then our excited hydrogen molecules, so in a gas state, will be exposed to this white light. And this will give us either an emission, or better, we can test for emission or absorption. Additionally, if we are to pass the same sample through this spectroscopy experiment, we will always get the same results. Same results, which is what suggests to us that electrons are in a fixed orbit around a nucleus. Now we just have to keep in mind that this is only applicable for hydrogen. Now, the emission spectrum would look like a black bar with, imagine that these are the rainbow colors from red to violet, and they would look a little something like this. And for our absorption spectra, it would look exactly the same, except that our base itself would not be all black, but would be all in rainbow. And what we would have is distinct black lines of the photons, which were absorbed by the excited hydrogen electrons. If we look at this here, maybe the first thing that we notice is that we have three distinct little sections where lines are present. Now these three are called series. And there's three that we need to be aware of. So if we were to draw, in fact, let me draw something out very quickly. So here we have a horizontal model representing different energy levels. So when an electron is excited up, the energy levels comes up and absorbs its photons, and it comes back down to energy level number 3. This tells us that it is in the passion series, meaning that it will emit infrared radiation. If our electron comes back down to number 2, then we say that it's in the Balmer series. And this encapsulates the whole visible light spectrum. And then if it falls right back down to energy level number 1, then we say that it is in the Lyman series, emitting the highest energy, the shortest wavelength, which is UV. If we look back over here at this little absorption or the emission spectrum, we may also notice this pattern, which is that closer to the end of the line sections, the lines seem to come very close together. They touch. And this is what we call convergence. What we need to know about convergence is that energy levels converge at higher energies, which is what gives us our converging spectral lines, which is why we see our spectral lines coming so close together over here at the end compared to at the beginning where they are more spaced apart, which is also what we see here in this diagram where the lower energy levels are more spaced apart from each other than the higher ones. That is all for 1.3.2. Thank you for watching, and I hope this was helpful.